Well, let us begin with the first session titled SORACOM and IoT in the Real World, led by Mr. Yuta Imai, Solutions Architect at SORACOM Inc. Now, ladies and gentlemen, please welcome Mr. Imai.
Hi, good morning, guys. To be honest, I'm feeling a bit nervous because this is a very, very first session of Rakuten Tech Conference 2017. But let me begin. So my name is Yuta Imai, working for SORACOM, which is the network and application platform for IoT. My background, previously I worked for Amazon and Hortonworks, which is Hadoop software company. So basically, I came from cloud and big data world. So let me take some questions. So how many of you guys ever heard of SORACOM? Wow, this is great. Thanks. And how many of you are engineers? Great, great. How many of you are back-end side or server-side engineer? 20%, 30%. Front-end side or client-side engineers? Oh, no one. Oh, 1%, thank you. And how many of you are the device engineers? Oh, thank you. So yeah, basically, as I said, I came from cloud and big data world, and now I'm working for the IoT world. So in IoT world, the engineers should be or must be kind of full stack engineer because we have to take care of the network and the devices. So today, I want to cover such technical challenges in our real customers. Let me begin. Good. So first, let me introduce SORACOM. So our service was launched in 2 years ago, September in 2015. So what we wanted to solve is something like this. The first issue is connectivity. So connectivity issue, so if we want to connect the things to cloud, of course, we need some connectivity. However, what approach should we take? So wired LAN or Wi-Fi, of course, it has some physical constraints. So here, 3G and LTE would be a good choice. However, still we have some challenges in contract because 3G and LTE type of cellular network is originally designed for humans. So still, it's not optimized for the things. And another challenge is security and management. For security, of course, we need some encryption or some protection for data. However, for small devices like sensors, something like that, the encryption is very, very expensive operation for such small devices. Also, management. What if the number of the subscribers or what if the number of the devices goes thousands or millions? Then we should take some kind of the automated approach for automation. So that is basically what we wanted to solve for the network in devices. So we started from cellular for things. We launched on September 13th in 2015. And you can buy it on Amazon, and we charge 10 JPY on daily basis and no minimum contract duration or no minimum usage. So that's the SORACOM Air, our first service. Yes, it's SIM card. So of course, you can install our SIM card to your smartphones and tablets. Then you can connect to the internet as you can use our SORACOM SIM as a usual internet SIMs. However, what is the SIMs or cellular for things? the first benefit, agility. So as I mentioned, you can buy it online from single SIM. You don't have to commit the number of SIMs or subscribers. And the price model is pay as you go. So basic fee, we charge 10 JPY per daily basis, no minimum term. And we also charge a data communication volume, 0.2 JPY per megabyte. It's totally pay as you go model, no minimum volume, no minimum commit. And self-service. Our service is fully functional via API and web console. Here I have some movies. The table and rows describe, each row describes each SIMs or each subscriber. And you can find we are changing the speed of SIMs on top of web console, which ranges from 32 kbps to 2 Mbps. Not only changing the speed in real-time manner, we also can provide the traffic usage monitoring in real-time manner. Even you can set some kind of the event handler, say something like if the traffic volume goes up 1 GB per day, then we can send email to you for notification, or even you can terminate the sessions, and or you can even terminate the contract. So that's a very, very tiny part of our SORACOM platform. Basically, I want to say that our services is totally available via API and web console. So you can manage the SIMs and the subscribers like EC2 on Amazon. So Amazon provides the EC2 as a API managed virtual servers. Like that, we provide API managed cellular network. So that's a SORACOM platform. Actually, most of us came from Amazon, including me. Okay, so yes, what we are doing is, so the things cloud, that's a part you create. What we do is we connect your things and cloud. So that's the SORACOM platform. Okay, this is a tech conference, so let me talk about how does it work, how it works. So SORACOM platform starts from, the communication starts from the devices and SIMs, of course. And we use mobile carrier. We are a startup company, so we are not, we don't have any facility. We are a software company. So maybe some of you guys ever heard of the word MVNO, Mobile Virtual Network Operator. We are one of the MVNO. So in Japan, we are using the NTT Docomo's network. So mobile carrier means the NTT Docomo in Japan. And from NTT Docomo to SORACOM, actually we are running on top of AWS Tokyo region and the SORACOM platform here. And between NTT Docomo and the SORACOM platform, we use leased line, or I would say Senyosen. From there, of course, you can go through to the internet. And some case, you might need a private connection to your cloud service, like AWS or Microsoft Azure or Google. So we provide such kind of capability. I will talk about it later. Of course, you can go to your data center in private network. Also, I will cover it later. So what is happening on top of the SORACOM icon? We implemented the PGW. PGW stands for the Packet Data Network Gateway. You can Google the PGW. Maybe you can find some kind of the telecom terminology, PGW. So on top of here, inside PGW, we are doing the, of course, authentication, the subscriber, or I would say SIM authentication. Then authenticated SIMs can go through the AWS or internet. So we have to do the the network translation between cellular or radio world to IP network world. So protocol translation, then routing and forwarding, of course, and traffic and usage management, because we are running on top of pay-as-you-go model. So of course we have to measure the network usage in real-time manner. And billing. So we are running such kind of functionalities on top of Amazon as a software. So it's software, so we can deploy anywhere on cloud. So it means we started from Japan. Of course, we are a Japanese company. We deployed, as I mentioned, we deployed SORACOM platform on top of AWS Tokyo region. However, today we cover global coverage. So we have another deploy on top of AWS Frankfurt region. Also, we are providing some kind of private deploy, or I would say white label deploy for KDDI. So we can do such kind of thing because we are the software company. We don't have any hardware or physical facility. We are software. So that's the SORACOM platform. Yes, we started from cellular. However, today we also cover various radio technologies, not only 3G, 4G. So we also covered LoRaWAN and Sigfox. How many of you guys ever heard of LP1 or low power wide area network? Oh, some of you. Thanks. I know. Yeah. So comparing to cellular network, as it describes, LP1 or low power wide area networks has a specialty in the power consumption on the radio emission at the device side. Also, it covers a wide area, wide range. So with very low battery consumption, it can emit the radio wave. I would say the range would be the 5 kilometers to 10 kilometers. So you can cover the kind of local, for example, you can cover the big factory or big parking lot or something like that with LPWA. So not only cellular, we, as I mentioned, we also covers LoRaWAN and Sigfox. And we also covers not only the radio part, we also covers the back-end part, the secure connectivity to your cloud. So this is the diagram I mentioned before. So far I covered the radio part of our service platform. Also, we are providing various or series of functionalities in SORACOM platform for your application services. For example, SORACOM Beam provides kind of secure proxy to your devices. I would talk about it later. And SORACOM Funnel provides a kind of secure proxy, especially for the AWS, Google, and Microsoft Azure. And in some case, you might want or you might need a private and closed network to your data center or to your office. Then you can choose SORACOM Canal Direct Door. For example, SORACOM Direct provides the least line connection to your data center between SORACOM and your data center. And with SORACOM Door, you can do that with IPsec VPN. And if you are using the AWS, you can use Canal for private peering or private connection between SORACOM core network and your AWS network. And SORACOM Junction provides a packet level inspection capability. You can mirror all of your packet to your, say, IDS, IPS, so you can monitor each single packet going through SORACOM platform. And Also, we are providing some kind of device management capability, SORACOM Gate and SORACOM Inventory. So with these services, you can manage the devices, not only the networks. So that's the SORACOM platform. So what we want to achieve is so kind of like this. Today we cover cellular network and LPWA. So we want to, of course, we want to extend our capability for the wireless capability. Maybe 5G networks and narrowband IoT will come up in the near future. So we want to go kind of wireless agnostic network provider. Also, cloud side, I can say same things. Today we cover AWS, Google, Azure, and the private cloud and private data center. Also, of course, internet. So if some new type of cloud service comes up, we want to cover the secure connectivity, that new cloud or something like that. So here we can also say cloud agnostic. So we want to achieve is, yes, this SORACOM connects every wireless and every cloud in secure manner. So that's the world we want to achieve. Okay, let's talk about the customers. So today, over 8,000 customers are using SORACOM platform all across the world. So here's the collection of the logos from the customers. The left up part, we collect the enterprise customers. Maybe most of you guys know the name of the companies like Komatsu, Daido, IHI, Yamaha, Lexio, Canon, Jaguar Land Rover. And the upper right side collects the our startup customers. FarmNode. FarmNode provides the automation and management service for the farmers. And Kakashi is very similar to FarmNode. The Kakashi is the company mainly working for the United States market. They are providing the how can I say? Sorry. E-scarecrow. So they're providing the kind of devices with cameras and some other sensors, and the customers can buy it on Amazon or the web. Then the customers can install that type of sensor device on their farm or on their field, so customers can sense the environment and the condition of their field or farm. And Lineup and PhotoSynth, they are provider of the smart lock. So maybe you can imagine we definitely need the kind of smart lock type of capability, for example, in Airbnb or something like that. And the downer side collects our partners. Of course, IoT world, only with network, you cannot do anything. Of course, you need devices and cloud and some other networks. So we have bunch of and series of partners which they are providing. Some of them providing the devices, and some of them are providing some kind of the packaged solutions, IoT type of packaged solutions, and some of them are providing the SI capability. So this is the main topic of today. So what is the IoT in the real world? What are the challenges, or I'd say what are the technical challenges of the actual customer? So The typical, so first, let me introduce the typical IoT applications, or maybe you can imagine smart meter type of applications. This is the use case from Osaka Gas, the gas company, which covers the western part of Japan, and vehicle management from the Lawson. We have a lot of convenience store in Japan, so it means that they are establishing, or they are running the very sophisticated logistic network. So on top of that, of course, they need vehicle and fleet management, and remote monitoring, or I'd say remote sensing. The Yanmar is the provider of the tools and services for farming. So they are testing, and they are studying some kind of the future farming with SORACOM. And typical architecture. So what would be what does it look like, the typical architecture of IoT applications? So of course, it starts from gathering or collecting data. So I will talk about the SORACOM Beam and SORACOM Funnel. However, they are the the services for data collection. So the first part, of course, you need the pipeline like Apache Kafka, Google PubSub, Amazon Kinesis, Azure Event Hubs, data collection. Then kind of real-time processing or stream processing, dashboarding, data lake, ad hoc queries or ad hoc analysis, or BI, business intelligence analysis, and machine learning, and even you might need some kind of edge computing at the device side. So this is a typical architecture of the IoT world. I think maybe many of you guys are already familiar with this type of architecture, right? So the Kafka, Apache Spark, and I would say Hadoop type of architecture. So this is a very basic and famous architecture, right? So then what is the difference of the applications so far? So that is here. Devices and networks are part of your application. This is a part totally different from the previous or the applications so far. So what I mean is, so with IoT applications, you have to take care of the cost of manufacturing devices, firmware version or firmware version up, because most of the IoT devices is physically and widely distributed. So you cannot collect and update it and redistribute. Once you deploy the devices, you can't touch it. And many devices are very constrained, and they have only small capabilities. So normal IoT devices does not have OS, operating system, so it's not flexible. So configuration management would be also the challenges, and radio network management or radio range management would be another issues, and encryptions. As I mentioned, most of devices are constrained, so encryption is a very expensive operations for them. And power management or battery management is also the big issue for this type of architecture. And subscriber management, traffic management. If the number of the subscribers or if the number of devices goes millions, you have to automate the management of them. And cloud connectivity. So this is the challenges and the difference from the applications so far. So once you manage or once you clear all of these type of things, then you can collect data to your Kafka or to your Amazon Kinesis. So we have to, so IoT applications, we have to manage them first. Oh, I forgot to mention the wire security between SORACOM and cloud. So today, I have 20 minutes more, so I will dive deep about the three real use cases. First one is remote monitoring. So the company name is Will. They provide the personal mobility, and it's, of course, they also provide support. So for better support, Will is collecting operational data of each single vehicles. But how? Challenge here is the power efficiency. So this personal mobility vehicle is running on top of the battery. So when we collect the data from this vehicle with encryption, then the batteries will be consumed. But it means the lifetime of the battery goes down. So that's a very, very big challenge for them. So the high-level architecture of what they are doing is they are installing SORACOM SIM on top of their vehicles, and they are using SORACOM Beam for data security. So what is SORACOM Beam? SORACOM Beam is, as I mentioned, it's a kind of secure proxy. We provide the host name, proxy host beam.soracom.io, which is a reverse proxy. So you can send data to your devices can send data to beam.soracom.io with unencrypted, because the radio access network and mobile carrier to SORACOM, it's a closed and private network, so you don't have to encrypt the data between here. Then inside beam.soracom.io, we will do protocol translation like HTTP to HTTPS, MQTT to MQTTS, or even TCP to HTTPS. Then we will throw the data to your backend, pre-configured backend. So that's a SORACOM Beam with encrypted, encrypted. So it means that, okay, let me go back to the previous slide. So it means that their Will's mobile vehicle does not have to pay the cost for the encryption at the mobile device side. So it means that they can have longer battery life for the mobile vehicle. So that's a benefit we are providing for Will. I also want to emphasize that not only encryption. Encryption is, of course, it's a very, very expensive operation. However, in radio world, the radio emission itself is also the battery consumption things. So if you use HTTPS for sending, I would say, for example, 20 bytes of data, you have to pay 5 kilobytes of overhead. So it means that more radio emission, then your battery life goes shorter. So actually, and finally, the Will chose to use UDP from devices to SORACOM for longer battery life. Okay, second use case, it's Dido. Maybe you guys have ever heard of Dido, which is the beverage company, and also they are providing the beverage vending machines. And they choose SORACOM to data collection over 105,000 machines. So that's a lot. So this is their challenges. What they are doing is high-level architecture is something like that. They choose to use SORACOM funnel to data collection into AWS environment. So SORACOM funnel is very, very similar to SORACOM Beam. That's another secure proxy for your devices. We provide the endpoint name, funnel.soracom.io. Then, so your devices can send data to funnel.soracom.io with unencrypted. Then we will send data, or we will forward that data to some specific cloud services like Amazon Kinesis Streams or Kinesis Firehose, AWS IoT Event Hubs, and Google Cloud PubSub. So that's the SORACOM funnel. And what I want to say here is for the cloud API, like AWS API and Azure API, Google API, you have to configure credential to your client side. However, what if the number of devices is like this, 150,000? You want to put your credential to your each single devices. That would be the nightmare. So Funnel provides a credential store on server side, so you don't have to put credential to your each single devices. Then we will do protocol translation, authentication. Also, we are doing buffering and error handling at the client side. So you don't have to have the buffer on your device side. Once your devices send data to SORACOM funnel, you can do something like fire and forget type of things at your device side. So your devices can use HTTP, TCP, and UDP, and you don't have to put credential on your devices. This is great because what if the devices will be stolen? If the credential inside the devices, it means that your credential will also be stolen. So putting credential on cloud side is very, very good benefit for the customers like this. And yes, they have challenges because their devices are very, very constrained in small capacity, and they have no OS and physically widely distributed. Still, they have to manage a bunch of devices. So what they are doing is leveraging our API. So we are providing the real-time monitoring for traffic usage and online, offline type of things through API. And the connect and disconnect logs via API. So when they think some of the devices might be going something wrong, then they can find the suspected devices via API by monitoring the traffic usage. Then once they find which devices could be wrong, then they can check the connect and disconnect log. And this is a bit different type of capability, which is called event handler. So customers can fire event. The customers can fire event when, say, traffic volume goes over 1 gigabyte per day, or then they can do some kind of the session termination or decreasing bandwidth, or I would say terminating contract could be done. And also, like Amazon EC2's tag capability, we also provide the tagging capability for each single SIMs. So you can put metadata for each subscribers, and devices can access to that metadata with unencrypted data because SORACOM network is secure. And email lock. So email is something like the MAC address for modems. And SIM is, so with email lock, we can couple the SIM to each specific modem. So it means that if the SIM itself will be stolen, that SIM does not work with another email or another modem because we are coupling that SIM to the modem. So that's the email lock. So of course, they have bunch of some other challenges, and however, this is a part of the effort for the management automation with SORACOM. And the last one, device management, from Komatsu. So smart construction. Smart construction is the name of the service which is Komatsu is providing. So with smart construction, customers can send design data to construction vehicles. And that construction vehicle, or I would say IoT construction vehicle, will be operated accordingly to the data sent from the cloud side. So this is great service for the vehicle operators. What is their challenges? So they need fully capable private IP network peering with Microsoft Azure VNet. So that is the challenge for them. This is high-level architecture of the Komatsu. The right-hand side, the blue icon describes a Microsoft Azure VNet. And the left-hand side, of course, it describes the construction vehicle. So they are installing SIMs on top of their vehicles. And through SORACOM platform, they have established the IPsec VPN between SORACOM network and Microsoft Azure. And on top of that, they are achieving the bidirectional or two-way communications between the vehicles and the cloud. And technically, what they are doing is, so basically we are providing the private IP address to the SIMs, say 10.127.0.0/9. And that packet goes through the SORACOM core network, which is 100.65.xy/24. This network will be allocated to each customers. Then, okay, let me go back. So from here, you can go through the internet. But if you, in such case, you need private network peering. We are providing the SORACOM Door, which provides the IPsec VPN capability from SORACOM network to the customer network. But still, you can find a NAT between the device network and SORACOM network. So it means that the servers on cloud side cannot initiate the IP communication to the devices directly because the device network is hidden. Hidden inside of the NAT network. So here we are providing the SORACOM gate. SORACOM gate is kind of the overlay network capability on top of this peered networks. So when you use SORACOM gate, we will provide the overlay network from device to your cloud. Or I can say that you can put all of your devices and servers into one single subnet, which is, for example, 110.127.0.0/9. So that's a SORACOM gate. So with this, Microsoft Komatsu is achieving the bidirectional and two-way communications between vehicles and Microsoft Azure Cloud. Oops. Okay, still a lot to cover, but I'm running out of time. But actually, I miscalculated my presentation. I still have 6 minutes, so let me summarize it first. So in the IoT world, devices and networks are part of your application. That is very different from the application so far. And often the devices, the so constraints, so you have to manage them. So that is the challenges. So that is the SORACOM we wanted to solve. So SORACOM provides a series of functionalities which help you to develop the IoT application and, or I would say, offload your device management or network management with the series of services like SORACOM Beam, Funnel, Harvest, and those kernel, direct, door, junction, gate, inventory. So this is the SORACOM platform. But actually, we started from the service from SORACOM Air, the SORACOM Air, and then we go to SORACOM Beam, and then we go to SORACOM Kernel, Direct, Funnel, SORACOM Gate. Like we are naming the service from SORACOM A, B, C, D, E, F, G, H, I, J. So that's the SORACOM platform. So that's it from my side. So sorry about the kind of disorganized presentation, but we still have 5 minutes, so I'm open for the questions. So any questions so far? Hopefully. Or if you have some specific request for the use case inside of this collections of logos, I think I can talk about that. Go ahead.
I have a question regarding software e-gateway you mentioned initially.
Can you wait for the microphone, please? There.
So I have a question regarding software P-gateway, which you have initially mentioned. What is the applicability in the market? Is it intended to the MVNO kind of players, or it is also applicable for the VNO kind of players?
Sorry, I could not catch. Can you say again? The P-gateway is intended to
MVNOs, mobile virtual network operators, or you're targeting that to the MNOs?
Oh, okay. Makes sense. So question is, P-gateway is intended for the mobile network operators or general, not only mobile network operator. Sorry. P-gateway is only for MVNO or the MVNO and MNO. So the answer is the P-gateway is the facility for the mobile virtual network operator. And so far, the P-gateway was the major provider of the P-gateway is Ericsson, Cisco, and some other network companies. And our point is I think we are the first one implementing the P-gateway as a software and running on top of it the kind of cloud. So that's our P-gateway. Does it answer your question?
Yes. So do you have some MVNO customers for the P-gateway?
Oh, good question. Yes, okay. So we have some MVNO customers. As I mentioned, we are providing the private deploy for KDDI. So kind of we are NTT Docomo is the MNO, and we are MVNO. Then, in addition, we are selling this P-gateway functionality to KDDI. So that's one of our use case for the MVNO customers. And also, we have some other MVNO customers. The name is Wameijin and eConnect Japan, which is the provider, the SIM provider for the tourists coming to Japan. You might need a SIM card for coming from the foreign countries to Japan. So that's another use case.
Thank you. Thank you so much.
Go ahead, please. The mic is coming.
Thank you very much for your very special speech. And I have a question about some. If you have any difficulty or challenge still, I'd like to appreciate if you share us. For example, for sometime I don't know about in deep technology about your area, but if I can imagine if we are lost in the middle of ocean or the higher mountain in any jungle in Africa, if we can connect to, still connect, it's very good. But can you do that too?
Okay, good question. So right now, with cellular networks, we are covering the 120 countries with our single SIM. But still, if no radio, like middle of the jungle or the middle of ocean, it's not production yet, but we are working with a satellite company like Scapa, JSAT, or some other companies. And today we are the subsidiary or part of the KDDI group. We are acquired by KDDI, and the KDDI is also they're providing the satellite capability. So it's not still production, but we are working. Okay, 3 seconds. One more question. Okay, that's it. Thank you very much. Thank you for your time.
Thank you very much, Mr. Imai.